Good day everyone, I am Najma Rajab and today we will back again with another activity which is the activity 4 factors affecting solubility, nature of solute and solvent. So my objective are to introduce to you what is solubility and what are the factors affects the solubility and give you some examples to further understand how those factors affects its solubility. So without further ado, let's begin.
But let us first define what is solubility. So in chemistry, solubility is ability of a substance, the solute, to form a solution with another substance, the solvent. Insolubility is the opposite property, the inability of the solute to form such solution. So in layman's term, solubility is a degree to which a substance dissolves in a solvent to make a solution. So, factors that affect solubility. The first one is the rate of stirring, particle size, temperature, and nature of solute. But let us first discuss how rate of stirring affects the solubility of solute. To further understand how rate of stirring affects the solubility, here is the example of sugar and water solution. The other cup is being stirred and the other cup is not being stirred. So as we can see, so the solute in the cup that was being stirred dissolves faster than the solute that is not being stirred. So I have here some animations to further understand the rate of stirring.
Solution. The blue circles represent the particles of water, while the red square represents the sugar crystal. Stirring the solution, let the water particles come in contact faster with the corners and edges of sugar crystal. Therefore, the sugar crystal dissolves faster. Now, let us compare how fast the solute dissolves in solution, which is stirred fast, stirred in moderate speed, and stirred slowly. The solution that is stirred fast dissolves fastest. The solution that is stirred in moderate speed dissolves next. And the solution that is stirred slowly dissolves last. This indicates that the faster the stirring, the faster the solute dissolves in a solvent.
The second one is the particle size. The crushed table salt is put into the beaker A and the uncrushed table salt put into the beaker B. The particles of crushed salt is smaller than the uncrushed salt. So, stirring both of the solution, observation, all of the crystals in crushed salt dissolve in water while there is still a single amount of uncrushed salt in beaker B. Therefore, the smaller the solute particle, the faster it will dissolve in a solvent. The third factor that affects solubility is the temperature. In this experiment, the other cup is filled with hot water and the one is filled with cold water. 1 spoon of coffee were added in those cups. Observation: the coffee in the hot water dissolves faster, spread faster than in cold water. This is because the water particles of hot water move faster and come in contact more often with the coffee powder, making it dissolves in a short period of time. Therefore, the hotter the solvent, the faster the solute will dissolve. In general, the solute dissolves faster in hot water than in cold water, but it is not always the case because the nature of solute also affects how fast it dissolves in a solvent. For example, these two cups are filled with hot water. The cup 1 has sugar and the other cup has salt. Stirring both of the solutions, Observation: the sugar dissolves completely while there are still few amount of undissolved salt. Thus, the sugar dissolves faster than salt in hot water. Now, let us proceed to cold water. These two beakers are filled with cold water. The other one has sugar and the other one has salt. Stirring both solutions. Observation: the salt dissolves completely while there are still few amount of sugar. Thus, the salt dissolves faster than sugar in cold water. Therefore, regardless of temperature, the nature of solute affect how fast it will dissolve in a solvent. Generalizations: in rate of stirring, the faster the stirring, the faster the solute dissolves in a solvent. In particle size, the smaller the solute particle, the faster it will dissolve in a solvent. In temperature, the hotter the solvent, the faster the solute will dissolve. And the last one is nature of solute. Regardless of temperature, the nature of solute affects how fast it will dissolve in a solvent. I also conclude that solubility is important to describe the substance, to indicate the substance polarity, to help to distinguish it from other substance, and as a guide to application of the substance. Good day everyone, so we're back again with another activity, which is the factors affecting solubility, pressure. So how pressure affects solubility? So according to Henry's law has important applications. The higher the pressure above a liquid, the more gas that can be dissolved in that liquid, to a limit of course. The solubility of gases depends on the pressure. An increase in pressure increases solubility, whereas a decrease in pressure decreases solubility. So to further understand it very well, let us do some experiment. So materials, any carbonated drinks. Procedure: shake a bottle of carbonated soft drink and cautiously uncap the bottle. So my observation, after shaking the soft drink vigorously and cautiously uncapped it, it caused a dramatic decrease in pressure over the liquid, and the CO2 starts to leave the liquid very rapidly, causing a mass exodus or explosion of bubbles. Generalizations: shaking the soft drink can introduce a lot of small bubbles into the liquid. The dissolved gas can more easily vaporize by joining existing bubbles rather than forming new ones. By avoiding the difficult step of bubble formation, the gas can escape more quickly from shaken soda, thus resulting in more fizz. And also, gases as might be expected increase in solubility with an increase in pressure. Henry's law states that the solubility of gas in a liquid is directly proportional to the pressure of that gas above the surface of the solution. So when the bottle is open, the pressure above the solution decreases.